Intro. Hello everyone. Welcome back to our channel. Today, we're diving into an incredibly exciting and critical topic in the world of artificial intelligence and machine learning: building a production-ready AI workflow. If you've ever wondered how to take a machine learning model from the initial data ingestion phase all the way through to deployment, you're in the right place. We'll be discussing MLOps best practices that can streamline this process and ensure that your AI models are reliable, scalable, and efficient in a production environment. So, let's get started. What is MLOps? Before we dive into the workflow, let's quickly define what MLOps is. MLOps, or machine learning operations, is a set of practices and tools that aim to deploy and maintain machine learning models in production reliably and efficiently. It combines the principles of DevOps with machine learning to ensure continuous integration, continuous delivery, and continuous training of models. As machine learning matures, MLOps becomes essential for managing the complexity of deploying and monitoring models at scale. Step 1: Data Ingestion. The first step in building a production-ready AI workflow is data ingestion. This is where we gather data from various sources for analysis and model training. Data can come from different places, including databases, APIs, logs, or even real-time streaming sources. It's important to choose the right ingestion method based on the type of data you're dealing with. A common approach is to use ETL, extract, transform, load, processes. This means extracting data from various sources, transforming it into a suitable format, and loading it into a storage system like a data warehouse or a data lake. Tools like Apache Kafka, Apache Spark, and Airflow can help automate these processes. Moreover, during data ingestion, it's essential to ensure data quality. You want to make sure the data is clean, relevant, and accurate to avoid garbage in, garbage out. Remember that one of the MLOps best practices is to establish a version control system for your datasets. This allows you to keep track of changes over time and revert to previous versions if needed. Using tools like DVC, Data Version Control, can help you manage your datasets efficiently. Step 2: Data Pre-Processing. Once you have ingested your data, the next step is pre-processing. Data pre-processing is crucial as it prepares your data for the model training phase. This involves cleaning the data, handling missing values, normalizing or standardizing features, encoding categorical variables, and more. A common practice is to create a pre-processing pipeline that automates these tasks. Libraries like scikit-learn provide tools to build these pipelines easily. You can also use frameworks like TensorFlow or PyTorch, which allow you to define custom data processing functions. Another important aspect of pre-processing is feature engineering. This is the process of selecting, modifying, or creating new features that will help improve the model's performance. The goal is to provide the model with relevant input that can enhance its predictive capabilities. Perform exploratory data analysis to understand the relationships within your dataset, which can guide your feature selection. Step 3: Model Training. After pre-processing the data, we move on to model training. This is the phase where we select an appropriate machine learning algorithm and train our model using the prepared dataset. Depending on your problem, you may choose supervised, unsupervised, or reinforcement learning algorithms. It's crucial to experiment with different models and hyperparameters during this phase. Use techniques like cross-validation to ensure that your model generalizes well to unseen data. Tools like Optuna or HyperOpt can help automate hyperparameter tuning. When training your model, implementing best practices such as tracking your experiments is essential. Tools like MLflow or weights and biases can help you keep track of different model iterations, their performance metrics, and configurations, which is vital in an MLOps environment. Step 4: Model Validation. After you've trained your model, it's essential to validate its performance. This step involves assessing how well your model performs on a separate validation set and, eventually, a test set. You should look at various performance metrics relevant to your task, such as accuracy, precision, recall, F1 score, or AUCROC for classification tasks. Furthermore, it's essential to evaluate the model not just quantitatively but also qualitatively. Conduct error analysis to understand where your model is making mistakes. This can help you iterate back to the data pre-processing or feature engineering steps if necessary. In this phase, you should also check for biases in your model's predictions. Fairness and ethics in AI are critical, so ensure that your model does not inadvertently discriminate against any group. Step 5. Model deployment. Once you're satisfied with the model's performance, it's time to deploy it into a production environment. This step can be daunting, but with MLOps best practices, it can be streamlined. You have several options for deployment, including on-premise servers, cloud services like AWS SageMaker or Google AI Platform, or even edge devices for IoT applications. Containerization is a popular approach for deploying machine learning models. Using Docker allows you to package your model along with its dependencies, making it easy to deploy in various environments. Kubernetes can manage container orchestration, ensuring that your model is scalable and can handle the load. Implementing continuous integration and continuous deployment (CI/CD) pipelines for your models is also crucial. This ensures that any new changes, whether in the model code or the data, can be automatically tested and deployed without manual intervention. Tools like Jenkins, GitHub Actions, or GitLab CI can help you set up these pipelines effectively. Step 6. Monitoring and maintaining the model. After deploying your model, the work isn't done. In fact, monitoring and maintaining your model is one of the most critical steps in the AI workflow. You need to continuously track the model's performance in the production environment to ensure it remains reliable and accurate. Set up monitoring solutions to track key performance indicators, KPIs, related to your model's predictions. This includes metrics like latency, throughput, and prediction accuracy. Tools like Prometheus or Grafana can be used for monitoring and visualization. Another essential aspect is setting up alerts for model drift. Model drift occurs when the statistical properties of the input data change over time, leading to degraded performance. Regularly retraining your model with fresh data can help mitigate this issue. Implementing a retraining pipeline as part of your MLOps practices will ensure that your model stays relevant and accurate. Step 7. Documentation and compliance. Throughout this entire process, don't forget the importance of documentation. Documenting every stage of your workflow is crucial for transparency, reproducibility, and collaboration. This should include everything from data sources and pre-processing steps to model configurations and deployment strategies. Moreover, with increasing regulations around data protection and AI ethics, ensure that your models comply with relevant laws and regulations. This includes data privacy regulations like GDPR or CCPA, which dictate how you collect, store, and process data. Conclusion. And there you have it. A comprehensive look at building a production-ready AI workflow from data ingestion to model deployment using MLOps best practices. Each stage in this workflow is critical, and following these best practices will help you create reliable, scalable, and efficient AI solutions. Remember that creating a successful MLOps pipeline requires collaboration among data scientists, data engineers, and IT professionals. By working together, you can ensure that your AI models are not only high-performing but also maintainable and compliant. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the notification bell for more content on AI, machine learning, and MLOps. Let us know in the comments what topics you'd like us to cover next. Thanks for watching, and see you in the next video.